Pretty happy with my solution to this problem. Have a look at the official solutions. They do it in a really concise way. My maths is, I've got to be honest, is not developed enough to write it. Especially when you're doing a problem in real time, it's easy, I suppose, to go back and make it more concise. But I'm going to talk through how I approach this problem. So we've got the numbers from 1 to 5. And then Claire and Stuart are playing this game, Nifty Nines, and they pick one of these numbers. Numbers can be repeated, and then basically the game ends when n numbers have been chosen, and we're interested in the sum. If the sum is a multiple of 9, then Stuart wins, and if it's not, then Claire wins. So we're trying to work out when Claire can win. So my approach here was just to start out with some values. So n equals 1, for example. Claire will always win because whatever she picks, she's not going to get a multiple of 9. N equals 2. So Claire, so she picks first and then Stuart goes. Claire will win if she picks a number less than or equal to 3. Because even if Stuart then picks 5, the most they're going to get is 8. So I kind of did this, and then I thought, oh, is this really getting me anywhere? I'm gonna look at, gonna think about this a bit, in a bit more depth. And actually, if Claire is going last, which she is in all the odd valued n cases, I don't need to do any more of them. She can definitely win. She can just avoid getting a multiple of 9 by selecting whatever number doesn't give a multiple of 9. So for any odd n, Claire picks last. So can always avoid the sum being a multiple of 9. And I went a bit further if picking k gives such a multiple, then she can pick k minus 1, or if that's not possible, for example, if k was 1, she can't pick 0. So the alternative would be to pick k plus 1. Yes, that's pretty good. I've argued why Claire can always win for an odd n. So now we need to think about the even values of n. Although Claire can definitely win for n equals 2, we need to show whether it's possible for all, or if not, why not? Um, the question seems, I mean, you can't always judge a question because maybe it's possible that Claire can always win, but you're kind of thinking probably in this sort of question, there's going to be some values of n where Claire cannot win, and that's going to be the hard bit. We're either showing that she can always win, or we need to find out the values when she can't win and explain why. So let's have a look at it. For even n, Stuart picks last. So Claire will pick second last. And at this point, the sum will be from 9k, so a multiple of 9, so 9k plus 8, all the way one less than a multiple of 9. So when I did this question, I decided to split it into these 9 cases and look at them separately and see which ones Claire can win for. Okay, let's do this. So case 1, 9k. If Claire picks 1, then Stuart cannot obtain 9, the next one on. It should be 9k plus 9 or this. Okay, same again here, because the highest you can get is 9k plus 7 if Claire picks 1. This one the same as well. But 9k plus 3, if she picks 1, then Stuart can pick 5. If she picks 2, Stuart can pick 4. So actually, this seems to be a bit more problematic. Here, she cannot guarantee a win. If she picks K, not K, K is a really bad one to you. If she picks M, then Stuart can pick 6 minus M to get to 9k plus 1. Okay, so we're going to have to come back to that, I think. Let's keep going with the other ones. So 9k plus 4. Okay, so if now she can pick, if Claire picks 5, she'll be okay. Then sum will be Stuart cannot stay on this or reach the next one along. Okay, now it's the same again, but she could pick 4. Here she could pick 3. Basically, we're always guaranteeing that she ends up on a multiple of 9, so Stuart cannot. Okay. So we've seen that she can win, except if on her second to last go, she is on 9k plus 3. So how can Claire avoid this? On her penultimate go. she can use the same above strategy in green to avoid getting there. Except when on her previous turn, she is on 9k minus 3. Because if she's on 9k minus 3, then whatever she adds, Stuart can add 6 minus that to get to 9k plus 3. So you can see this like cycling problem occurring. And she can avoid 9k minus 3, except if she is on 9k minus 9. Because if she's on 9k minus 9, again, Stuart can guarantee that they add 6. So on her third to last go, she cannot be on a multiple of 9. And that's going to cause problems when n is equal to 6. Because we could, if she puts down 1, Stuart can put down 5. So that would give us 9 minus 3 as our sum. And then if she puts down 2, Stuart can put down 4. That will overall leave us with 9 plus 3. And then she puts down, say, 5. Stuart could put down 1. And that would overall mean for a 9 plus 9 or 18. So Stuart can win here. And he will be able to, for any n that is a multiple of 6, by repeating the above strategy. I haven't said it. I've said it out loud. I've not actually written down what it was, but always making sure he gets the 6 when you pair them up. So basically, pick 6 minus m when Claire picks m. So where are we up to in this problem? We've shown that Claire can always win if n is odd, because she goes last. We've seen some scenarios when she, as long as she avoids n 9k plus 3 on her penultimate term when n is even, then she can win. We've seen that that is not guaranteed when n is 6 or a multiple of 6, and explained how Stuart can actually win. So we're just left to looking at the other even values of n. We've not actually shown that she can devise a strategy that will necessarily win. It feels like it's going to be possible, but we need to state it. So 2, 4, 8, 10, and so on. Now these ones are in the form 6k plus 2. So we're going to look at that case. And then these ones are in the case 6k plus 4. So let's look at 6k plus 2 to start with. That's my value of n. Let me write that down. Okay, so we can now kind of use the same sort of strategy that Stuart had, although we're going to start with 3. I think a similar thing would happen if you started with 1 or 2. Then, if Stuart picks M, Claire should pick 6 minus M. So it's going to look a bit like this. 3 and, oh yeah, this would be for 2 turns or 8 turns and so on. We know that 2 is already possible, so let's focus kind of on 8 here. So 3, and then Stuart would maybe pick 4, so Claire would pick 2. That's what I mean. We can guarantee a pair of 6 here. And then let's say Stuart picked, not 6, we can't pick 6. Stuart picked 5, then Claire could pick 1. And then if Stuart picked, I don't know, 3, then Claire would pick 3. So at this point, we're up to 3 times 3 lots of 6, which is going to be 21. And there's no way that Stuart can get to 27. So this would work. But what about in general? So it would actually be 3, and then we'd get some lot of 6, some lot of 6, and so on. And so it would be 3 plus, right, now we've got 6k plus 2 moves. So there's going to be Claire's move, then there's going to be another 6k moves, and then there's going to be Stuart's move. Let me write down what sorry, I'm not explaining this as well as I'd like. So Claire's going to put down 3, and then they're just going to it's going to put these pairs of 6. Claire can guarantee that, except Stuart's got the very last move. But what we're going to end up with, therefore, is 3k lots of 6. Because there's 6k moves here, and whatever Stuart puts down, Claire puts down a number to guarantee 6. So overall, we've got 3k lots of 6. And then we've got Stuart's move plus Stuart's move. So this will equal 18k plus 3 plus Stuart's move, which means that we are actually we're at a multiple of 9 with 3 more than a multiple of 9. So Stuart cannot win here. 3 more than a multiple of 9 before Stuart's move, so he cannot win. Okay, brilliant. So that strategy will work for Claire. N equals 6k plus 2 can be won by Claire. Guaranteed. So that just leaves us with n equals 6k plus 4, which is going to work in a very similar way. So this time it's going to be 3 followed by the 6's again. So it's going to be 3 plus, this time it's going to be, we're going to have Claire's move, then we're actually going to have 6k plus 2 moves involving these pairs. So we're going to get 3k plus 1, lots of 6. And then Stuart's move. I just want to explain this a little bit more. So Claire's gone and picked 3 at the start. I've not written that down. I would write it in my full solution. And then whatever Stuart puts down, Claire puts down whatever will give a value of 6. So because we've got 6, we've got a move, and then we've got another 6k plus 2 moves. That means whatever we have, we're gonna have 3k plus 1 pairs of 6. Claire can guarantee that, and then we've got Stuart's move. So this time we're going to end up with 18k plus 9 plus Stuart's move, which is 9 times 2k plus 1. So actually this time we're at a multiple of 9 when Stuart has his move using this strategy. So again, Stuart cannot win. Claire can guarantee a win for n equals 6k plus 4. Therefore, Claire can guarantee winning except for n equals 6k. Phew. Okay, I know that was very involved. There's a lot of writing there. I'm not saying this is the perfect solution, but this allowed me to get a feel for what's going on because I believe in the examiner's report, people just didn't know, when there was difficulty for Claire, and this kind of really helps see where that is and also why. So, seeing how Stuart can ensure that he wins when n is a multiple of 6. Actually, when I did this, I stopped at this point, kind of congratulate myself. I didn't actually show a strategy for n equaling other even numbers, which is what I've done now. Um, and I hope that you're happy that this is comprehensive. I think I mean, I need to kind of, like, if I was doing it in the real thing, I need to like explain it a little bit better, but I've explained it verbally as well as writing it down. Finally, let me just show you the solution. Like when you're doing a problem like this, you're not gonna probably come up with something like this straight away. You're gonna have to play around with it a lot more than just write down this single thing. So that's why I didn't want to just present this is how you should do it. It's quite technical. It's nice. So give it a read, compare it with how I explained it. But yeah, a hard problem as always with these question fives. We tend to get these different games going on, and you have to show whether the person can win or not, and look at strategies. But that's what I've done. Well done for making it to the end of this video, and hopefully you're happy with this question. Thanks.